Okay, the next topic is out of bag evaluation. So when we are doing the bagging classifiers, and remember we are drawing some of the samples from the training set. So even though it seems that we are using the training set X train and Y train for the training, and remember we are only using a subset of the samples. So we are drawing the samples, and for the other of the samples we didn't draw from the training set. Actually, well, they have not been seen by the classifier. So it is okay that we are using the leftover samples in the training set for a evaluation, right? So that is called out of bag evaluation, and the leftover samples in the bag of the training set, and we call that out of bag instances or OOB instances. Okay, so those instances, OOB instances, can be used for evaluation purpose as well. So after training the bagging classifier with the X train and the Y train, well, we can use the OOB score to get the rough idea. So it seems that we got the 90.1 something. So this is the performance on the leftover samples of the training set. So if we are using the testing set, and we should roughly get the same thing, right? So and then we evaluate the performance on the testing set, and then we got a 91%. So well, they're roughly the same thing. And well, just now we say there is a bagging and there is a pasting. And then we say, okay, for the bagging, there is a bagging classifier. So how about the pasting classifier? Okay, you can do a search, and do you see anything built in into scikit-learn called pasting classifier? I did a search and I didn't find it. So the next question is, well, why we can't have a pasting classifier? The answer is, well, we can change the bagging classifier into a pasting classifier, and take a look on this documentation, and you will be able to find how to draw the samples with or without the replacements. Okay, so well, this is my answer, and that is here. uh where is it? Okay, bootstrap. So bootstrap equals false, and then if we specify the bootstrap equals false, even though this is a bagging classifier, but we are drawing without replacement, and that is pasting. So we have a pasting classifier. However, in this case, we can't do OOB score anymore. Okay, OOB score is only for bagging. Okay, so well, when we did a bagging classifier with the bootstrap as a false, so we find, well, that's a performance almost the same as we had from the real bagging classifier. So why? So why there's almost no difference? The reason is when well, this X dataset, the X test, well, this is a relatively small dataset anyhow. So when we have a small dataset, usually it doesn't matter too much if you're doing the bagging or pasting. However, doing bagging is more popular in most of the cases. Okay, and another thing I want to remind you is for the max samples. So the max samples is a parameter here, right? So for the max samples, we can use two variants. One is if you are using the integers and we are specifying how many samples are we drawing. And there's another case that we can use the float numbers, and then that is how many percentage of the data we are drawing, and it should be a float value from 0 to 1, of course. So well, let's try something interesting. Let's try the max sample to be 30%, and then the max sample to be 90%. So I did both. And what I found was if we only draw 30% of the data, we got the 92%. However, if we are drawing the 90% for each of the predictor in the ensemble, we got something even worse. Hmm. So think about it. If we are making ensembles and for each of them we only use 30%, actually putting together all the predictors into an ensemble, it is better than we make up another ensemble for each of the predictors. We use 90% of the data. So why? Okay, this is my answer. The answer is by keeping a small portion of the dataset to feed, and then feed that into each of the predictor, and then we are likely to have independent predictors. Okay, if we go extreme, if we go with 100%, what is that? We have an ensemble. However, for each of the ensemble, they are using 100% of the training set. So they are roughly the same decision trees. And when we have 100, well, when we have 500, okay, when we have 500 estimators and they are using almost the same training set, they are not independent anymore. That is the reason that even though we are using a higher percentage of the training set, actually we did even worse. Okay, so this is the part we want to pay attention to. Okay, to sum up, well, in this lecture we talk about the voting classifiers, and the basic idea is we want to make use of the wisdom of the crowd. And well, one way is we can create a bunch of different classifiers. However, there's a limit. Well, the better idea is we use either bagging or pasting, and then we are using one ensemble of the same type of the machine learning model. However, we feed each of the model or each of the predictor with a independent subset of the data. Okay, and finally we talk about the bagging classifier, and inside the bagging classifier, if you want to do a pasting classifier, remember that is also doable. Okay, so that's it for today, and I will see you guys tomorrow. Bye.